By now, you are probably aware of the significance of properly differentiating between different enantiomers. Enantiomers are two different compounds with different properties, and we must indicate it. To do so, we will use the prefixes R and S in front of the IUPAC names. Like for all the nomenclature that we have seen until up now, there are some rules that we must follow. Once you have identified the chiral center, we must assign priorities to each one of the four groups connected to it. The highest priority will go to the group with higher atomic number, in this case, the bromine. And the lowest priority will go to the one with the lower atomic number. It will often go, but not always, to the hydrogen. If two atoms are the same, we look at the atoms that those are connected to. For example, in this molecule, at the bottom right, we have oxygen, carbon, carbon, and hydrogen. To break the tie between the carbons, we will look at the atoms that those are connected to. One of them, the primary carbon, is connected to 3 hydrogens. The secondary carbon is connected to 2 hydrogens and 1 carbon. Because of that, the latter will have the priority. If you encounter 2 isotopes connected to the chiral center, the one with the higher mass number will have priority. For example, hydrogen has a proton, but deuterium, its isotope, has a proton and a neutron. Deuterium will therefore have priority over hydrogen. If there is a double or a triple bond, simply assume that the carbon is 2 or 3 times connected to that group. In this example of a carbonyl, we will assume that the carbon is connected to 2 oxygens and a hydrogen. In the case of a double bond, it's equivalent to being connected to 2 carbons, and the triple bond is equivalent to being connected to 3 carbons. Pause the video here and take a minute to understand why the following chiral centers present those priorities. Now, let's label these 2 enantiomers as R and S. First, assign the priorities to the groups based on their atomic number. In this case, O will be the highest and H will be the lowest. With the lowest priority group pointing away from you, look only at positions 1, 2, and 3. Then, trace a circle that goes from 1 to 2 to 3. If the circle goes clockwise, your molecule will be R. It may help you if you remember that in Spanish the word for clock is reloj. If the circle goes counterclockwise, then the molecule will have an S configuration. It is very important that you put the lower priority group pointing away from yourself. If that doesn't happen, then you have to rotate the molecule until group 4 is pointing away from us. The more obvious way to do that is to rotate the molecule physically, but that's not always easy to see in paper. I will attach a document where you can find some ways to make sure that the lower priority number stay away from you.